everyone! This is the first in a two-part video about the laws of exponents. So let's get started. Now there's around 8 main laws that you should know. In this video we'll cover about 4 of them. So let's look at the first one. When you have any base a raised to the n times the same base a raised to another exponent n, then you just add the exponents. So let's look at an example. If I have 5 raised to the third power times 5 raised to the second power, then that would give me 5. You keep the base the same, and you add the powers. So this would be 5 to the power of 5. What if I had, say, 11 raised to the negative 4th power times 11 raised to the positive 3rd power? That gives me 11, we keep the base the same, raised to the negative 4 plus 3. So you add the exponent no matter what. And that would give me 11 raised to the negative 1st power. Okay, so whether the exponent is a negative or a positive value, it doesn't matter. If you're multiplying them and they have the same base, so remember this only applies when the bases are the same. So if the bases are the same and you're multiplying them, then you add the exponents. So let's look at the second one. If I have any base a raised to the n value divided by a raised to the n value, then that would give me a, the same base, and this time you subtract the exponents. So here, when we're multiplying, we added the exponents, and here, when we're dividing, we subtract the exponents. So let's look at an example. If I had 6 raised to the 3rd power divided by 6 raised to the 2nd power, then that would give me 6 raised to the 3 minus 2, which is just 6 to the 1st power. Okay, what if I had, say, 7 raised to the negative 3rd power divided by 7 raised to the positive 2nd power. Now, because you're dividing them and they have the same base, you still have to subtract the exponents, minus 2, which is 7 raised to the negative 5th power. Okay, so this is the basic rules for both. When you're multiplying with the same base, you add the exponents. When you're dividing with the same base, you subtract the exponents. Now, if you notice, here and here, we have a base raised to a negative exponent. So for these ones here, you could just solve it. You could put it into your calculator or you could solve it by hand. But when you have a negative exponent, what do? This leads us to our next law. When I have any base a raised to the negative n power, that gives me 1 over the base to the positive power, the same power. So this is the same one here. The power is the same and the bases stay the same. All you do when you have a negative power is you invert it. You go 1 over the same thing here, except the exponent becomes from negative to a positive. So let's look at the previous example. Here we had 11 to the negative 1st power, so this would be 1 over 11 to the 1st power. And anything raised to the 1st power gives us the value itself, so this is just 1 over 11. Over here, it's 7 raised to the negative 5th power. That gives me 1 over 7 to the 5th power. So I think you can get the hang of it now. Let's look at this one again. So if I have a to the negative n power, remember it's just 1 over the same base raised to the exponent. What if I had 3 over 2 raised to the negative 3rd power? what would you do? So you know that if it's a base, you just invert it, but here it's a fraction. What do? The same rules apply. So what you do is you switch the fraction around. The denominator becomes the numerator, and the numerator becomes the denominator. So you switch them around, and now you raise it to the same power, but positive. Okay, and you could solve this further. 2 to the third is 8. 3 to the third is 27, and that would be your answer. What if I had 1 over 4 raised to the negative second power? Now here, when you had a base and a negative power, you switched it around, right? But here it's already 1 over the value. So what do? Again, the same rules apply. All you do is you switch it again. You go 4 over 1 raised to the second. Sorry, I'll write that neatly. 4 over 1 raised to the second power. And when you have 1 in the denominator, you don't really have to write that. So this just becomes 4 to the second power, which gives us 16. Okay, now let's look at the last law in this video. When you have anything raised to the 0th power, you just get 1. Okay, so let's look at an example. If I have 5 raised to the 0, it's 1. If I have negative 245 raised to the 0, I get 1. If I have 324 divided by 276 raised to the 0, I get 1. So anything raised to the 0 power just gives us 1. So let's look at this. What really is happening here? If I have a number raised to the first power, right? If I have 5 raised to the first power, just going back to this example, if I have 5 raised to the first example, what really is happening? I'm multiplying 5 by 1, right? So this is just 5 times 1. So anything raised to the first power gives us the value itself. But when I'm raising it to the 0 power, right? When I'm raising it to the 0 power, I'm multiplying it by none. I'm not multiplying it by itself. Instead, I'm multiplying it just by 1. So this gives me just 1. When I have 1 as the exponent, I have 1 of the base. When I have none of the exponent, there's nothing I'm multiplying it by, so it's just 1. I hope that makes some sense. So this derivation of the law is basically what we did here. So anything raised to the first power is the base itself. So 7 raised to the first power gives us just 7, because all we're doing is 7 times 1. If I have 14 over 25 raised to the first power, that is just 14 over 25. So I think you understand now. Anything raised to the first power gives us the value itself, and anything raised to the 0th power gives us 1. This is the end of this video. Make sure you watch the next one where I finish all the laws of exponents. Thank you.